Hello guys, welcome to the next lecture on the probability and statistics. Today I will explain you how you can deal with the multivariate normal distribution. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of probability and statistics, and you can see the previous lectures on the transformation of random variable, discrete two-dimensional random variable, as well as the distribution functions. Also you can see we have discussed about the normal distribution, uniform, exponential, all about here. Apart from them, you can also see there is a lecture on the bivariate normal distribution as I explained you in my last lecture series of here. Now, you can simply follow my YouTube channel for the complete course on the probability and statistics. So as I explained you, we have discussed in our previous lecture the normal distribution and the bivariate normal distribution and their various application. So we denoted the normal distribution as n with the two parameters mean and variance. However, on the bivariate normal distribution, which is denoted as bivariate normal, mu that is the mean of the x, mean of the y, variance of the x, variance of y, and this rho is called as the correlation coefficient. Now, based on this, we also describe that if you have the two independent random variable, then the sum of the two normal independent variable, like means x and y are my normal and they are independent, then the sum is also normal. However, if the two normal, if they are not independent, means if x and y are the only two normal random variable, then their sum may or may not be a normal. So that concept we already explained in the bivariate normal distribution. So how you can overcome that concept? That means when the variables are not independent and the sum is not normal, then we have described the bivariate normal distribution. That means the linear combination of them is a normal, then you can say it's a bivariate normal distribution. We also describe the probability density function of the normal and the bivariate normal variables. And graphically we also describe that this is the graphical representation of this and this is the variation of here. This is up to so far we have discussed about the normal and the bivariate normal. Now, what is the concept of this? Today's objective is we will see what is the concept of the multivariate normal distribution and what are the various parameters. So basically the multivariate normal distribution is basically the extension of the bivariate normal distribution from the two variable x comma y to the p variable, that means x1, x2 and up to xp. So clearly say it is clear that whenever p is equal to 2, that means this is my only two variable x1 and x2, then this multivariate normal distribution will reduce to the bivariate normal distribution. Fine. So that's why the multivariate distribution is the extension of the bivariate normal distribution. Now, what is the definition of the multivariate normal distribution? If you have the p random variables x1, x2 and xn, it may be independent or it may not be. The random variable xp, where p is greater than or equal to 2, are said to be the jointly normal or a single called as the Gaussian or called as the multivariate normal. So the word multivariate can be replaced by the jointly normal or it can be replaced by the word Gaussian. When the random variable x is said to be multivariate, if this property satisfied. First of all, if there exists p independent random variable. What is the p? P is the same as of this. If I say x1, x2 and x3, there are the three random variables. So there exists three another random variable which are from the normal distribution, that is called as standard normal variate. Why we call as the standard normal variate? Because the mean is 0, variance is 1 and another constant mu I. And a most important thing is a p cross p, that's a square matrix which is a non-singular. What is the meaning of the non-singular? Determinant is non-zero. Then we can write this x is the linear combination of mu and z. So any of the variable x is follows to be the normal distribution, multivariate normal distribution, if that x will satisfy this property. Fine. This is the definition of the multivariate normal distribution. Now, first one is if xi's are my multivariate normal distribution, then you have to find the mean and the covariance matrix. How you can find that? So look at that. As by the definition of this multivariate, because it is given that xi, I varies from 1 to p, is my multivariate normal distribution. That means, what does it mean? There exists, by the definition, we can written as x is mu plus az, where mu is my constant. Fine. A, what is the A is P cross P, non-singular matrix. Fine. It may be the symmetric matrix, it may be the orthogonal matrix, it may be the skew symmetric matrix. Any matrix, the only condition is it should be the non-singular. And Z is my normal distribution from 0, 1. So if it has a P, then we can say mu is basically, then what is the mu? Mu is basically a P vectors, mu1, mu2 up to the mu P. Similarly, this Z is also my Z1, Z2 and ZP, where each of the Zi's follows normal distribution 0, 1, and mu is my mean. Now what is your target? What is your target? According to the statement, you have to find the mean of the x and covariance of x. This is your target. Remember this, what is the x is? X is my x1, x2 up to the xp. This is the vector. Fine. This is always with the vector. That is always my p cross 1. Now, so in order to find the mean, you can see I can start from the e of x. It will be e of mu plus a into z. I can return this is e of mu plus a is my any of the singular matrix that has the real entries. So I can return this number as here. So it means I need the mean of the z, and since z is my normal distribution, so the mean of the z is 0, variance is my 1. So I can start from these equations. So what is that? If I write this value is mu of a plus a times of this. So mu is a constant value, so it is mu. What is the e of z? It's a 0. So that means the mean of this is my this quantity. Fine. Second is you have to find the covariance. So what is the definition of the covariance? It will be, so what is the definition of the covariance x comma y? It is my expected value of x minus mean of x into y minus mean of y. But right now we have there are the n variables, p variables. Then we can write this as here. So I can substitute this value of the covariance. What is the covariance of x? That is a mu plus a into z. Fine. Now how you can write the covariance? You can always know that covariance of x comma x, this is my variance of x, and variance of the constant value is 0. Variance of a of x, where a is my real number, is a square, variance of x, but where a is my scalar. So in this case I can start from here. Fine. So what is the x minus mu? I can start from here. What is x minus mu is az. What is the x minus mu is az transpose. What is the property of the AB transpose? It is B transpose into A transpose. So I can start from here. This is A Z. What is the transpose of this? Z transpose into A transpose. Now since A is my real non-singular matrix, so I can return this is A times expected value of Z into Z bar. Fine. Now since Z is my P cross 1, fine, Z bar is my 1 cross P. So if you multiply them, it will be my here. So what is the variance of this? What is the, if variance of Z is my 1, expected value is 0. What is my expected value of this? I can found from the variance plus expected value of the Z whole square, which comes to be I. So that means A I into A transpose. So what is that? I is my identity matrix, so this is A into A transpose. Fine, because this number is my I. Fine, because of this variance, because we all know variance of x is expected value of x square minus expected value of the x whole square. So this number is my here. So always remember, whenever you have to return this value, fine, then this will be the mean of the x, and the variance, or called as the covariance, is my A into A transpose. Second property, if xi is my multivariate normal distributions and the covariance matrix sigma, then prove that it is a positive definite. What is the meaning of the positive definite? If I say my matrix is 1, 4, 3, 7, for example, is it a positive definite? How you can check about that? It's a very simple. Look at the first diagonal value, 1 greater than 0. Second, find the determinant of this 1, 3, 4, 7. It is 7 minus, it is minus 5, which is not greater than 0. So it means it is not positive definite. Fine. If I look about this another example, 1, 4, 2 and say 1. What is the first diagonal entries? 1 greater than 0, satisfied. Second, determinant of this 4 minus 2 is a 2, which is greater than 0, is a positive definite. Now, so what we have seen, that sigma is my here, you can see, because you can write from, you can start from here. Let me clear this firstly. Now since xi's, where I varies from 1 to 2 up to p, are multivariate normal distribution, so this implies expected value of the x will be mu and sigma will be A into A transpose, where you have to write like this manner, where A is my P cross P non-singular matrix. Fine. So therefore you can write A is my non-singular matrix. Now how you can prove that is should be the positive definite? So that means you can take any x from the dimension of this sigma. What is the dimension of this sigma? Because A is my P cross P matrix. What is the A transpose? A transpose is also P cross P. What is the A into A transpose? Again into the P cross P. So that means sigma is my P cross P matrix. So take the column, number of the columns are my P. You can choose any vector x, and if you multiply this by x transpose into sigma x, if it is strictly greater than 0 for all non-zero x, then you can say it is a positive definite. So your target is to prove x transpose, this number should be greater than 0 for all x which is my non-zero. So I can assume that let x belongs to the Rp which is my non-zero. So I can substitute this value as here. What is the sigma is? A into A transpose. Fine. So that means x transpose A transpose x. I can written this number as A transpose x. Again, by using the same property, AB transpose is my B transpose A transpose, and this number as such here. Fine. Now you can see these are the same number, A transpose x and A transpose y. Fine. Now if x, what is the size of the x is? P cross 1. What is the A transpose? It is my P cross P. What is the size of A transpose x? If you multiply them, it will be my P cross 1. Clear? Now what is the size, what is the dimension of this? What is that? If you take the transpose, it will be my P cross 1 cross P. What is the dimension of this? It is my P cross 1. So if you multiply them, this is my 1 cross 1. That is my real number. Fine. Now look at that. What is given to you? A is my non-singular matrix. What does it means? Determinant of A is my non-zero. That means the rank of A is my P, that is called as the full rank, because the rank determinant is non-zero. So therefore A transpose is my non-zero, X is my non-zero, so the product will also be non-zero. Fine, because if Ax is my 0, for example, if Ax is 0, what does it means? Either A will be 0 or X will be 0, but X is my non-zero, so that means A will be 0. If A will be 0, then is it a non-singular? No, then it's a singular, so it means none of them will be 0. So we can say this is my non-zero. So this quantity is my non-zero. So if this quantity is my non-zero, what is the transpose of this? This is also non-zero. So this is non-zero, this is non-zero. Then the question arises is whether it's a positive or negative. So assume A transpose X is my negative. Then this is my negative. This is again a negative. So negative into negative is positive. So this is greater than 0. If A transpose X is my positive, then this is my positive, this is my positive, again is a positive. So in both the cases, it should be greater than 0. So hence, sigma is my positive definite. Fine. So what does it mean? Sigma is my positive definite, sigma is my covariance matrix. So I can say sigma is my positive covariance matrix. Fine. So from this onward, we will denote the multivariate normal distribution by here xp, or sometime I will denote it as x follows the normal distribution with the p variate having this notation, where this mu is called as the mean, sigma is called as the positive covariance matrix, and which can be written like A into A transpose, where A is my P cross P non-singular matrix. So always remember, whenever in the future lecture series, whenever I write X belongs to the multivariate normal distribution this, it means these two properties automatically satisfied. Okay, look at this another one. Now you can see I have written here, it means sigma is my positive covariance matrix. Then your target is to find the probability density function. Again, a very simple. What is given to you? It is given that X follows the normal distribution, multivariate normal distribution of here. What does it mean? That means X can be written as mean plus A of Z. Always remember, if I write here is this, say 7 plus, instead of the 7, if I say this is my A comma sigma, this is always the mu, that is a mean. So then X will be mu plus A into Z. So now, since X is my multivariate normal distribution, it means it satisfied this property, where mu is my constant, a real constant, A is my non-singular matrix, Z is my independent random variables, and sigma will be A into A transpose. Now, how you can find the PDF of this X? So clearly say, whenever you will find some kind of this, you always use the transformation. Fine. So that means like I can start from here, because we need a transformation by here. F of X, because this is a function which is dependent on the Z, so f g of Z, where g is the PDF of the Z into the Jacobian. This is called as Jacobian. So now I can start from Z. So since Z is my normal distribution and they are independent, so the probability of Z will be product of this. And Z is my normal distributions of the 0, 1. So we all know what is the PDF of the normal distribution 0, 1. So I can substitute that value as here, because what is this value? It is 1 over root 2 pi e raised to power minus Z by 2. Fine, or Z square by 2. So then since it's a vector, so instead of the z square, I have to return this number is z dash into z. Because of this product value, I can return like of this number. Remember, this z into z dash will be z1 square plus z2 square and up to zp square. And when you taken as a product, clearly say this number will be my summation of this, and this number is product of p. Now I need to find the dz by dx. So what is the z? Z will be a inverse x minus mu. What is the dz over dx? It will be a inverse. Fine. How you can find the a inverse? I can take it from here. Fine. So you can start from here. Inverse of this. So what will happen? I can take the modulus. This. It will be a inverse modulus and of a inverse. We all know determinant of A and determinant of A transpose is always same. So that means if I call determinant of this number is my x, then this is also x. Fine. So that means this number will be my determinant of A inverse square. So can you find the value of this? From here it will be root of inverse modulus. Fine. Now I can substitute this value in the PDF form. What is the g of z? I can substitute here. Substitute the value of the z here. Since it is a transpose, so I have to return this as a transpose. Again, because this is my z bar. So what is a z bar is a inverse x minus mu transpose. Again, I can use the same property. AB transpose will be B transpose A transpose. So it will be x minus mu transpose A inverse transpose. This is the here. Then you can see here, what is that? A inverse into A inverse transpose. So that will be AB transpose. Fine. Now this value is my sigma inverse of it. What is the AB transpose? AB transpose is my sigma. That is a positive covariance matrix. I can replace by sigma here. And this is the required probability density function of here. And you can always remember that whenever you are talking about the normal distribution, what is the PDF? You can remember that it is 1 over root 2 pi into sigma e of minus half x minus mu divided by sigma whole square. Fine. Or you can write this number in form of here 1 over this, or this is root sigma. I can separate it. It is minus half x minus mu whole square, and it will be the sigma square. I can return this is sigma minus of 2, and you can see the same thing 1 over root 2 pi. Now here this is my single x. Fine. Here we have the p variate, so this is written in the p times, so that means this number will be written the p. Sigma is my standard deviation, so you can see here it is a root sigma. Exponential of minus half, exponential of minus half. This vector I can return in this product form, that's a vector quantity, so I have written here. What is that? This is the 1 over sigma square, that means a variance, so you can see it is a 1 over variance. So similar manner I have to define PDF of the joint density function. Next result, it is given that if x follows my normal distribution called as the multivariate normal distribution, and you consider the another matrix B which is my non-singular. What is the meaning of the non-singular is rank of this matrix B is the same as of multivariate normal distribution. Then you can find the PDF of the matrix Bx which follows again the normal distribution, multivariate normal distribution, with the mean is this and the variance is here, B sigma of this. The proof is very, very simple. What is given to you? X follows here. Can you tell me what is the meaning of that? By the definition, you can return X is mu plus A Z, where what is the Z is? Z follows the normal distribution with 0, I and R independent, where A is my P cross P non-singular matrix and sigma will be A into A transpose. That's the definition of the multivariate normal distribution. Now your target is to find the Bx. It means I have to multiply equation number 1 by matrix B. So what is that? What happened? Bx is equal to B mu plus B A Z. Fine, that will happen. Now look at the very simple concept. Compare this equation again with the help of here. What will happen? That means if this will happen, it means Bx will follows the normal distribution with the mean. What is the mean? Is the first quantity, that is here, because it is independent of the X and Z. So the mean is my here. What is the covariance? This I call sigma B. What is the definition of this? Is sigma B will be A into A transpose. What is the A? How you can define the A? Which is the coefficient of the Z. What is the coefficient of Z? BA. So that means it is this into here. Fine. This will happen only if you prove that BA is my non-singular. Remember, this A is my non-singular. Then only you can define as a sigma. So is it given that BA is my non-singular? No. So you have to firstly prove that. Fine. So once you prove that BA is non-singular, then your result will be over. Now how you can prove that BA is my non-singular? I think it's very simple. Why? Because it is given that A is my non-singular, B is my non-singular. Fine. So what does it mean? BA is also non-singular. Fine. Clear? Because A and B are my non-singular. So non-singular means determinant of A is my non-zero, determinant of B is my non-zero. So what does it mean? BA is also my non-singular. Fine. Now once this property is satisfied, this is my real number because B is my P cross P matrix, mu is my P cross 1 matrix. So what is the B mu? B mu is again my P cross 1 matrix. So what does it mean? That means Bx follows the normal distribution with the mean here, and this capital D is called as the covariance matrix of what? Is it X? No. This is the covariance matrix of Bx. Or if you called Y is my Bx, then this is the covariance matrix of the Y. So what is the D? It will be A into A transpose. What is the non-singular matrix of the Bx? That is the BA. So that is here. Now I can open this bracket. It is my BA. Fine. Now it will be, what is the BA transpose? That is the A transpose into B transpose. So I can substitute this value. What is the A into A transpose? That is sigma into B transpose. So that means I can substitute this value here. You will get the same result of this one. Fine. And this result is very, very important in case of the multivariate distribution. So let me explain you with the help of the example. So what is that? X follows the normal distribution. So clearly say P will be my 3. Fine. What is my mu? Because it has a 3 vectors and mean is my 0. Fine. X will be my x1, x2 and x3. What is my covariance matrix? Again it is my 3 cross 3. It is given that identity matrix. This is the meaning of this first line. Then your target is to find the covariance matrix of the y. So firstly, can you return y in terms of here y1, y2, y3? This is my y. Fine. Now can you return this is, because this is a transformation, you know the value of the x, which is a multivariate normal distribution. Your target is to find the y by using the transformation. Fine. So can you write this matrix? x1, x2, x3. So what is the x coefficient of the first line? x1 is 0, x2 is 1, x3 is my 2. x1 is minus 1, x2 is 0, x3 is my 2. x1 is my minus 1, x2 is my 1, and x3 will be 0. Fine. So this is given to you as here. Now you can see that if you compare this equation by y is equal to bx, is the same of this. This will be my b, or if you want to write here is another number, say c, so then this will be my c. Fine. That's basically this is my linear transformation. Fine. So c will be my here. Now the what is the, because I consider y is equal to my cx, so y x follows my multivariate normal distribution. This is also follows the multivariate normal distribution with the parameter here c sigma c transpose. When you can return that? Only when you prove that c is my non-singular. Fine. How you can prove that c is non-singular? I can start from the determinant. First value is 0, then minus 1, it is a 0, minus plus of 2, then plus of 1, it is my minus 1. So it will be minus of 2 minus 1, which is minus 3, which is non-zero. So therefore c is my non-singular matrix. Fine. Don't forget to subscribe and like my YouTube channel. Now since c is my non-singular, so once c is my non-singular, so that transformation y is equal to cx or cx, this will follows my normal distribution. Y basically y is cx is follows my here, where what is c into mu? The value of the c is here 0, minus 1, minus 1, 1, 0, 1, 1, 2, 0. What is the mu? Mu is my 0 matrix. 0, 0, 0. So if you multiply them, you will get as 0, 0, 0. And covariance matrix is, this is called as covariance matrix. Fine. So c of this. So I can substitute this value. What is the c? Again, c will be 0, minus 1, minus 1, 1, 0, 1, 1, 2, 0. Sigma, this is my identity matrix. So I can substitute I as here, because I is my identity. So if you multiply them, and this is my C transpose. Now you can multiply them. What will happen? So first row, first column, it's a 1, 1, 2. First row, second column, 0, 0, 2. It is always the symmetric. Remember, it is always symmetric. 0, 1, 0. Second row, first column, 0, 0, 2. 1, 0, 4. 1, 0, 0. 0, 1, 0. 1, 0, 0. And 1, 1, 2. So clearly say this is a symmetric matrix. It means your calculation is correct. So 2, 2, 1, 2, 5, 4 is the covariance matrix of here. So from here you can what conclusion you can obtain from here? That means variance of y1. First value is my y1, second is y2, third is y3. Variance of y1 is 2. Variance of y2 is 5. Variance of y3 is 2. You can find the covariance between y1 and y2. That means this is also y1, y2, covariance between y1 and y2 is my 2, covariance between y2 and y3, y2, y3, 1, and so. So this is the way you can solve this as a simple manner. I hope you can like and subscribe my YouTube channel as well. We will see the next lecture some more results on the multivariate normal distribution. Till then, you can like, share and comment on my video. Best of luck students. Happy learning.